wrote this. So we have a function that's basically a product of 4 cosine x with a bunch of different cosine 2x as powers. Okay. So let's maybe break it down into separate functions first. So 4 cosine x, and we have minus 12 cosine x cosine 2x, and then we have plus 12 cosine x cosine square 2x, and then we have minus 4 cosine x cosine cube 2x. Now the first idea that comes to mind is, I mean, the thing is, this is easy to do. This is simple,
Wait,
so we
why
don't need to
12?
worry. Because 4 times 3 and 4 times 3.
Okay.
Yeah. So cosine x times cosine of 2x. That is interesting. Right. Oh, oops. I wasn't recording. So these are the general expansions of cubic binomials, okay? So if you have a
Okay.
plus b whole cube is going to be like this, a minus b whole cube is going to be like this. The reason I noticed this is because when I saw this expanded form, I had this feeling that this is a cubic because there was a cube here. And secondly, because the coefficients matched perfectly with Pascal's triangle's fourth row. The fourth row corresponds to third degree polynomials. Okay? These
Okay.
are the coefficients of third degree polynomials. So you have 1, 3, 3, 1. 1, 3, 3, 1. I was just confused about whether it's going to be a plus b or a minus b, but since I have a minus here and here, second and fourth term, just like I'm supposed to, see, I knew that this whole thing, the whole function, is actually just this. 1 minus cosine x. Cosine 2x, sorry. Because all of them are cosine 2x's. So this is what your function is, or cubed. And that makes life much, much, much easier because this question is simply a substitution problem now. Now, of course, I haven't gone over substitution with you in detail yet, but it's very easy. I'll show you by example here. The steps are always going to be the same. Okay, first of all, when do you need substitution? You need substitution whenever you have a function that is trapped inside another function. Okay, you see how 1
Mhm.
minus cosine 2x is trapped inside a cube? That's when you need substitution. What do you substitute? You substitute u to be the thing that is trapped. So 1 minus cosine of 2x in this case. Okay, so
Okay.
this is where you begin. So the observation that 1 minus cosine 2x is trapped inside another function, and then using that guy as your substitution. That's your first main step. Now, second step is always the same. Derive your substitution, du over dx. Find that out. What's the derivative of 1?
Doesn't it just disappear?
Yeah, it becomes 0, exactly. And what is the derivative of minus cosine 2x?
Sine of 2x?
Minus 2 sine of 2x. Well, what's the derivative of cosine first? It's negative sign, right?
Yeah.
And when you derive something like this, you have to multiply it by the derivative of the inside of the thing too. Chain rule. So you have to multiply this by 2 because that's the derivative of 2x. Okay?
Yeah.
So you end up with just 2 sine 2x. Okay. Now make dx the subject. Okay? So I'm going to flip, I'm going to take dx up there and take the 2 sine 2x down here. Are you following?
I'm
Take a
just
second
trying to
to.
process the sine part because I'm good with
Okay.
integration and
Yeah.
differentiation, but
Let's figure
I
that
get
out.
mixed up when it comes
hmm
with trig.
So basically, chain rule, what does chain rule say, right? Chain rule says that if you ever see a function that is inside another function, right? You need to derive the outside part first and then multiply by the derivative of the inside part. Okay, that's the way I kind of visualize it. So now, similarly, you have cosine 2x, cosine of 2x. First, derive the outside. What is the derivative of cosine? Negative sign, right?
Yeah.
Keep the inside the same for a second. See, the inside is the same right now. And then multiply by the derivative of the inside. What's the derivative of the inside? 2x.
2.
So that is why the derivative of cosine 2x is negative sine 2x times 2. Okay? So first
So
the
we
outside.
differentiate we differentiated cos of 2x with chain rule.
We have to, yes, because you have a function cosine and another function trapped inside the cosine, 2x.
Okay, that makes sense.
Yeah. So we can do more examples on chain rule after this, when we get to differentiation. But yeah, that's the general idea. So you're gonna end up with well, you already have a negative here, so it's gonna be positive now. So positive 2 sine 2x. Because you see there's a negative here. So
Yeah.
it's gonna cancel out this guy. Okay. Now, the goal, by the way, right now is that we're trying to replace everything in this integration with u stuff instead. So you see you have cosine x, 1 minus cosine 2x, and then you have dx. We're gonna replace all of these with u's, okay? We've already figured out how to replace this guy with a u. I mean, that was just explicit. Um, my suggestion to you, my educated suggestion to you is that don't worry about cosine x right now. It'll figure itself out in a second. You'll see it. Or maybe it won't, who knows. Anyways, dx is the thing we're working on now. So we need to convert dx to something du related instead. Okay. And to do that, we derived u. Okay. We derived u to get this. And now we're going to make dx the subject so that we can say that dx is equal to this. So what is dx? Can you try to make dx the subject and tell me what you get?
Can you write it as can you write it as du over 2 sine 2x?
Exactly. du over 2 sine 2x. Perfect. So now we know what dx is. We know what u is. I mean, we know what 1 minus cosine 2x is. Let's replace what we know and then figure out what else we need to do. So the 4 cosine x, it's kind of hopeless. We don't know what to do about it yet, but let's figure out the rest. 1 minus cosine 2x is u, and dx is just du over 2 sine 2x. So far, so good?
Yeah.
So this, everything we did here was just basically, what's the word? Trying to figure out a substitution and replacing x's with u's. This was setup. But we're not done yet. We need to figure out how to remove this cosine x and cosine x and sine 2x from here because they're still x things. We need purely u stuff in here. Okay, here's an
Yeah.
idea. Any ideas, by the way?
Mm, not sure.
So whenever you have a situation like this and you're like, okay, I need to cancel stuff out somehow, but I don't know how to, think about identities. What identity can I use here? What is sine 2x equal to? It's equal to 2 sine x cosine x, isn't it? It's in your formula booklet, by the way.
Okay.
Yeah. So we can replace sine 2x with that. Okay. So we basically have 2 sine x cosine x here, right? And we can, okay, let me just rewrite this because there's another 2 here. So we're going to have 4 cosine x u cubed du over 2 times 2 sine x cosine x. Be careful, there's another 2 sitting here and another 2 that comes from the sine 2x itself. Okay. Now from
Yeah.
here, the 4 and the 4 cancel each other out. The cosine x and the cosine x cancel each other out. So far, so good?
Yeah.
Nice. So now we have u cubed over sine x. That's still annoying because what is sine x now, right? But for this case, all we can possibly do is go back and think about what u was. U is 1 minus cosine 2x, right?
Mhm.
Okay. We need to somehow think about if u is 1 minus cosine 2x, what would sine be? Okay, that's the question. What I'm going to do is I'm going to use the identity that cosine 2x is also possibly written as 1 minus 2 sine square x. That's an identity. Okay. I'm going to
Okay.
replace cosine 2x with that. And then I'm going to make sine x the subject. So let's do 1 minus 1 plus 2 sine square x. The ones cancel out. So u equals 2 sine square x. Divide both sides by 2 and then square root to get sine x. So if u is 1 minus cosine 2x, then sine x has to be square root of u over 2. Do you agree?
Um, Give me a moment to like process all
Okay,
of that.
yeah, process that. It's a long one.
Okay. Yeah.
Okay, so now let's replace sine x with root of u over 2. Okay, by the way, immensely difficult question to start with. I hope that you're following. But
I'm
yeah,
following.
we'll
I'll
do
probably
much easier
rewatch
questions.
this.
Okay, good, good, perfect. So now u cube over u to the power 1 over 2 over, well, the thing is, I'm gonna, first of all, there's a little algebraic thing. If you have a denominator under a fraction, you can pull that to the top. If you want to know why, watch this. A over B over C over D, for example, is the same as A over B divided by C over D, right? Same thing, right?
Hmm.
And in elementary, they tell you that if you want to divide two fractions, you can multiply them by flipping the second fraction, right?
Yeah.
So you see where the bottom D came up? It came to the top. The denominator at the bottom can jump to the very top, basically, is what I'm saying,
Yeah.
because of this. So that's why I pull the denominator at the very bottom to the top. Now, or you can just pull it out because I don't like constant factors in difficult questions. Make things look more difficult than they are. So you have this now. So far, so good?
Yeah.
Good. So now we have u to the power of 3 divided by u to the power of 1 over 2. I think this is the easiest step. What am I going to do now? Combine them into one power by subtracting their powers. Indices, remember?
Yeah.
Because they're dividing same base, so I can subtract their powers. So we have this, and that becomes u to the power of 5 over 2 du. And finally, after all of that, my integral is perfectly substituted and ready to be integrated. So I now get u to the power of 7 over 2 divided by 7 over 2. And that is my, well, not my answer, because unfortunately,
Mm.
the question says that we need to plug in m now, right?
Yeah.
So that's fun. Let's plug in, let's clean this up first a little bit. Let's just remember that we have to plug some stuff in still, but anyways, root of 2. 2 comes to the top again, denominator at the very bottom jumps to the top. Very useful trick, by the way, you should know this. In integration especially, because you're going to have a lot of fractions on fractions.
Yeah. Yeah.
You have this now. And finally, we can now remember that u is supposed to actually be 1 minus cosine 2x. Since u is just 1 minus cosine 2x, it's all raised to the power of 7 over 2. I can finally plug in my boundaries, okay? Which were m to 0, or 0 to m. Let's do that. Oh, wait a second. Yeah, never mind. Oh, wait. Yeah. So now let's plug in the boundaries. 1 minus cosine 2m minus 1 minus cosine 2 times 0, which leaves me with 1 minus cosine 2m minus 1 plus cosine 0, which is just 1, right?
Yeah.
The ones cancel out. That leaves me with 2 root 2 over 7 times 1 minus cosine 2m. Nice. Oh God. Wait a second. There's a to the power of 7 over 2 over everything. Forgot. 7 over 2, 7 over 2 here. Same thing here. And made a little mistake there actually. Minus 1 minus 1 to the power of 7 over 2. Doesn't change anything, but still. Because this is still 0 and this is still 0, it doesn't matter. But,
I have a question.
uh,
Why is this not included in the thing that we're substituting? Like, why is it not like this?
because the thing is, In fact, in integration, you will quickly, when you do enough practice, you'll realize that it's always useful to take out, what's it called, like multiplication factors. If you had to write this every single time, you'd have it here, 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 and here. Instead of writing it all 4 times, I just take it out in the very beginning and don't have it part of it. Because
Oh, okay.
multiplication factors, like early on, I took it all out of the integration. It doesn't change anything. You can just
Mm,
multiply everything by 2 in the end. It doesn't really change anything, right? So I highly suggest that because especially this, mess, it wouldn't be nice to have to write it every single time. It can make the thing look more difficult than it is. So
yeah.
yeah, because in AA, because it's so focused on like approach and analysis, they're gonna give you messy situations to work with because they want to see if you can like approach it properly, like, do your working properly. And the easiest way to do that is to not write repetitive, useless things that can just be taken out, you know.
Yeah. Okay.
Um, yeah. So now you have this. However, the problem is the answer is supposed to look more like that. 32 over 7 sine to the power of 7m. Thankfully, we've already used something that we will use again. Okay, let me show you. We already know, no, so that recall that cosine 2x can be written down as 1 minus 2 sine square x. Okay, this is an identity again, by the way. It's again in your formula booklet as far as I remember. You're gonna
Yeah.
have 2 root 2 over 7 times 1 minus, instead of cosine 2m, I'm gonna write one bracket, of course, 1 minus 2 sine square m. Okay, and everything is of course still raised to the power 7. Okay, I just replace cosine 2m with this.
All
Now
right.
I have 2 root 2 over 7, 1 minus 1 plus 2 sine square m to the power of 7 over 2. And the ones cancel out. And we have this. And finally, one thing. So you have sine square inside and 1 over 2 outside, right? I mean, ignore the 7 for a second. You know that if you have a power on a power, you can multiply the powers, right? This is
Yeah.
a law of indices. So the 2 and the square cancel each other out. The division by 2 and the 2 cancel each other out. So you end up with 2 root 2 over 7 times 2 sine to the power of 7m. Okay.
Okay.
Oh, my bad. There's a 7 outside. I didn't, because if when I put the 7 in, the 2 will also get the 7. Both of them will get the 7. So finally, my final answer will be this guy times 2 to the power of 7 times sine to the power of 7m, which leaves me with whatever that is. So just multiply all of this stuff together and you will probably get, I mean, hopefully get 32 over 7 somehow. Yeah. So yeah, that's basically it. Made a mistake. Sorry. One sec. So you know how, okay, let me show you what the mistake was actually, because it's important. The mistake was when I had this
Yeah.
2 sine square m to the power of 7 over 2, I said that I'm canceling out the 2 with the 2. But that can't happen because the 7 over 2 is applying to 2 and to sine square m.
Oh, yeah,
Okay.
yeah, yeah.
So we have to do 2 root 2 over 7, 2 to the power of 7 over 2, and sine square to the power of 7 over 2. Both
Right.
of them get 7 over 2. And of course, the 2 does cancel out here, but it still applies to the 2. Okay. Oh, so now we have 2 times root 2, which is 2 to the power of 3 over 2. And we have times 2 to the power of 7 over 2 also. If this is non-calculator, then this is a why it's non-calculator, because you're supposed to kind of figure out these indices yourself. 2 times root 2 is 1 plus 1 over 2, which is 2 to the power 3 over 2, times 2 to the power 7 over 2, which will add up to 1.5 plus 3.5 is going to be 5. And there you go. Proven. I did not see that coming, I'll be honest with you. I
See
did
what
not
coming.
see that this question would be this long. I thought it was going to be like half the size. But
It's a
yeah,
nine marker, so I'm not
yeah,
surprised.
immensely difficult question. Even like I can't believe this is AASL. This is an
Yeah,
AAHL
me
problem.
too.
Very, very, very difficult
I
problem.
was questioning in my head if I like accidentally took this from a HL paper. Like I
Yeah.
actually genuinely like I need to check because what the hell?
Yeah, the thing is, if you can understand how to do this question, you can prove to yourself that you're a pro at a bunch of things. Number one, you're a pro at substitution. Number two, a pro at chain rule, differentiation. Number three, trigonometric substitutions, like these things. Not, sorry, trigonometric identities. And on top of that, you like are amazing at factorization, sorry, simplifications and like,
Yes.
targeted
Yeah, yeah.
simplification. So, I mean, the thing is, a question like this, make sure that once you found it, make sure that you understand it fully. Because
Yeah.
understanding something like this will give you so many skills. Like for small, like the other questions will seem like child's play to you now.
Because it has like so many different topics already.
Yep, yep. Okay, so the second part is not easy again. It says that it's given that if you integrate the function from m to pi over 2, you get 127 over 28. Find the value of m. Okay, let me think about this for a second. Ooh,
Yeah, take your time.
there's a very interesting trick to this second part actually that I want to show you. Okay, so we have so far found out that if you integrate the function from 0 to m, whatever the function is, I don't want to write down the whole thing, but when you integrate it, you get this, right? This is what we know from the first part. Now, here is the trick to the second question. The second question wants you to find out what this is, okay? But the problem is this integration does not look like this integration because see, the bottom was supposed to be 0 and the top was supposed to be a number. If it was like this, 0 to pi over 2, all I would do is I would literally just plug in pi over 2 over here and call it a day. But it's not 0 to pi over 2, it's m to pi over 2. By the way, do you understand why I would just be able to plug in pi over 2 in that case?
Can you explain it again?
Okay, so if this was the question, right? Then I would just draw the parallel. I would use my logic and look at the fact that it looks exactly the same except m is pi over 2, right?
Mhm.
So I would just plug in pi over 2 for m. That's exactly what they're trying to imply, right? Because everything else it looks the same. Integral of from 0 of the function dx. Top is m, I have pi over 2. I already know how to find a general sense integration where the top limit is m and the bottom limit is 0. So if they tell me to find the integration from 0 to like 5, I just have to plug in 5 here. If they ask me to find the integral from 0 to 10, I'll plug in 10 here. Because I know that
Yeah.
whatever the top number is shows up here. So whatever the top number is will show up there. Sine 7 of 10. You see what I mean?
Yeah.
So they give you a general formula and you can now apply that. But the problem is that our integration is not from 0 to m or 0 to a number at all. It's from m to a number. But here's the trick. This is general knowledge, by the way. The fact that if you have any integration like this, you can actually break it down into two separate integrals by doing this. You go from, um, you can go from 0 to pi over 2 of f of x and then subtract from that 0 to m of f of x. So this is something you can do. Why? Why is this true? You know the whole situation with like integration giving you area, right?
Yeah, that's exactly what I
Mhm.
just thought of.
Nice, smart. So if you want to find the area between these two values, let's say this is m and this is pi over 2, why not first, I'm gonna be a bit lazy and just copy this. Why not first find the area behind all of the pi over 2 and then find the area behind just m and subtract them. Won't that give you exactly what you want?
Mm?
So this is from 0 to pi over 2. This is from 0 to m. If you subtract 0 to m from 0 to pi over 2, you will get m to pi over 2. You see what I
Yeah.
mean? That's exactly why this works. And why am I? Oh, Why am I deleting this? And why am I doing this though? Like, what's the point? Why am I making things more complicated? Because I've already gone through about 20 minutes of pain trying to find out how to find the integral of f of x from 0 to any number. So if I can break down my integral to be a bunch of 0 to a number integrals instead, see, 0 to pi over 2 or 0 to m, it will make my life much easier because I just need to do a bunch of plug and play situation now. So now what I do is, once I've realized this, I will now replace 0 to pi over 2 with 32 over 7 times sine to the power of 7 of pi over 2. Because again, top number shows up right there. See? So I've used the general formula in my situation. Does that make sense so far?
Okay. Yeah.
Okay, and then minus, this is m, so it's just going to be 32 over 7 sine to the power of 7 of m. Okay. And the fun thing is that they've already told me what all of this mess is supposed to equal. It's supposed to equal 127 over 28. Okay. They've already told me
Okay.
that. So I'm going to keep it like this and then let's try to solve that equation. Can you tell me what sine of pi over 2 is? Isn't it 0? It's 0, isn't it? No, it's 1. Yeah, sine of pi over 2 is
Yeah.
1. So this whole thing is just 1, which leaves me with 127 over 28 equals 32 over 7 minus 32 over 7 sine to the power of 7m. Okay.
Okay.
Now, let's subtract 32 over 7 on the left side. What is 127 over 28 minus 32 over 7?
Sorry.
What is 127 over 28 minus 32 over 7? So like subtract this basically on the left side. I'm trying to make 7, sorry, I'm trying to make sine the subject. Did you lose me?
No, no, I'm doing it.
No, okay. Kind of Frankenstein's monster have you brought today?
Hmm. Negative 1 over 28.
Negative 1 over 28 equals negative 32 over 7 sine to the power of 7m. The negatives cancel each other out. I'm going to multiply the 7 there. Um, yeah, that's all I can do here, honestly. 7 over 28 times 32. Can you, actually, I can simplify this in my head. 7 times 4, and that leaves me with 1 over 124, I believe. Am I right? 7 times, yeah, 4 times 32 is 124, isn't it? Yeah, 4 times 30 is
Yeah.
120. Yeah. Now, just take the seventh root of 1 over 124 because I need to make sine m the subject, not sine to the power 7m. I hope it's a clean number. I don't think it's going to be a clean number, is it? I mean, a whole number. Oh, seventh root, by the way, not square root. Are you finding it?
But I did this on my calculator though.
Did you, is this the seventh root of 1 over 24?
It's 7 times. Is this 7 times
No, seventh
or what?
root.
Oh,
Yeah, yeah, seventh root. Because I have a seventh power here, right? So I took the seventh root on both sides, basically. You know why, right? 0.50. Okay, good. Sine of m. You've lost your voice, I see. So
hmm.
now we can finally, to find m, just take the sine inverse of 0.5022, and that is finally going to be our answer. Unbelievable how long this question was. All right, are you here?
I have a question.
What's up?
Isn't this 1 over 128?
Is it? Oh God, it
I think
is. It
so.
is. It is. It is. It is. You're right. That makes okay. That makes more sense actually, because it's gonna be two then, isn't it? I think
Yeah,
it's 2 to the power 7 is 128, isn't it?
yeah.
Yeah, makes sense. So m is sine inverse of 1 over 2, which is something. I don't know what that is. But radians, by the way. So what is it?
1/6 pi.
1 over 6. 1 over 1 over 6, right?
6. 1/6 pi. I have a question.
Uh-huh.
Um, so we know that sine of 90 or pi over 2 becomes 1, but
Yes.
does it not make a difference if it's sine to the power of 7?
Yeah, because the thing is, if, okay, think about it like this. Sine to the power, so sine of 90 to the power of 7, right? What is sine 90? It's 1. So it's
Oh,
just 1. That's why. Good question, though.
okay.
So that is the end of this question. Let's finish the recording.